fit in the boxes. Stop it, quitting was never an option. Exhausted, this passion is never exhausted. And you cannot stop it, nah, you cannot stop it. Quitting was never an option. And you cannot stop it, nah, you cannot stop it.
Hey everyone, I'm Elizabeth Carson, and I'm thrilled to introduce to you an extraordinary weekend event happening right here in Miami, Florida on August 3rd and 4th. It's none other than the second annual Forbidden Conscious Awards weekends. After the tremendous success of last year's event with over 1,200 attendees from around the globe, we knew we had to make this year's event even more spectacular. On Saturday, we have a captivating conference lined up featuring world-renowned speakers such as Muhammad Ibrahim, Merkaba 13, Robert Grant, Billy Carson, and a women's panel hosted by yours truly. Following the conference, we'll set sail for a VIP yacht cruise at sunset, where you'll have the chance to mingle with your favorite nominees and celebrity guests, all hosted by 19 Keys. Sunday, August 4th, kicks off with a Forbidden Knowledge book publishing signing event, followed by the highly anticipated second annual Forbidden Conscious Awards. This is a red carpet affair, so come dressed to impress. Remember last year we surprised a lucky guest with an Audi A4 during the awards, and this year we're upping the ante with a chance to win a Mercedes-Benz. So make sure you secure your tickets early. This event is sure to sell out quickly. I cannot wait to see each and every one of you there for what promises to be an unforgettable weekend of education, inspiration, celebration, and glamour.
Hey everyone, it's Billy Carson, aka Forbidden Knowledge. Welcome to another amazing episode of the Forbidden Knowledge Podcast. You have heard me do lectures and podcasts talking about the nature of our reality. And in those lectures and podcasts, I often bring up the Adinkra codes. The Adinkra codes of the Dogon tribe, and a professor here in modern times that has deciphered an Adinkra code that runs the ether of space-time itself. Today, I'm bringing you the receipts as I was able to get Professor Sylvester James Gates Jr. on the Forbidden Knowledge Podcast. Now, who is he? Sylvester James Jim Gates Jr. is a distinguished theoretical physicist whose career spans several prestigious positions and significant contributions to physics. After retiring from the University of Maryland in 2017, he became the director of the Brown Theoretical Physics Center. He also holds the titles of Ford Foundation Professor of Physics, Affiliate Professor of Mathematics, and Faculty Fellow at the Watson Institute for International Studies and Public Affairs at Brown University. During his tenure at the University of Maryland, College Park, he held multiple roles, including University System Regents Professor, John S. Toll Professor of Physics, Director of the String and Particle Theory Center, and Affiliate Professor of Mathematics. Gates has also notably served on the U.S. President's Council of Advisors on Science and Technology, the Maryland State Board of Education from 2009 to 2016, and the National Commission on Forensic Science from 2013 to 2016. Professor Gates is renowned for his pioneering work in supersymmetry, supergravity, and superstring theory. He earned 2 BS degrees and a PhD from the Massachusetts Institute of Technology, where he wrote the institution's first doctoral thesis on supersymmetry. In 1984, he co-authored Superspace, which was the first comprehensive book on the subject. His leadership roles include past president of the National Society of Black Physicists, where he is also an NSBP fellow. He is a fellow of the American Physical Society, the American Association for the Advancement of Science, and the UK's Institute of Physics. In 2019, he was elected to the presidential line of the American Physical Society and currently serves as president-elect. He is also a member of the American Academy of Arts and Sciences and the American Philosophical Society, and in 2013, he was the first African-American theoretical physicist elected to the National Academy of Sciences. The same year, President Obama awarded him the National Medal of Science. Between 1991 and 1993, he was chair of the Department of Physics and Astronomy at Howard University and served as the founding director of the Center for the Study of Terrestrial and Extraterrestrial Atmospheres, USTA. His leadership facilitated the formation of MHATCAT, a collaborative research effort involving the synchrotron at the Advanced Photon Source beginning in 1994. Professor Gates has also held visiting professorships, including as the Rydell Visiting Professor at Gustavus Adolphus College between 2007 and 2013, and as the Roth Distinguished Scholar at Dartmouth College in 2015 to 2016. So, Professor Gates, welcome to the Forbidden Knowledge Podcast. Glad to have you.
Well, Billy, thank you very much. I tell people I'm not sure why young people like you want to talk to an old guy with white hair like me.
Well, you have a lot of wisdom and a lot of knowledge. And so those white hairs are accumulation of decades of knowledge that I think the world needs to hear.
Well, I'll do my best not to embarrass you or me.
Okay. Now when we look up your bio, and I just gave your bio to everyone, which was extremely extensive, and I wanted to make sure that I read every piece of your bio because I'm trying to establish a context here, that I'm not talking to somebody that just puts on a robe and slippers and makes posts online on a prepaid phone. Okay, we're talking to a scholar here, and I wanted people to understand that. And that I talked about you being an expert in supersymmetry, which basically is something that predicts the particles in the standard model, the spin rate. It has to do with spin rate and the particles in the standard model. Can you dive a little deeper into supersymmetry and exactly what it is?
Sure. Well, first of all, it's only a theory, but this is a theory in the esoteric sense of the word. It's a piece of mathematics. Part of it looks like our reality, and part of it we've never actually observed in the laboratory, and that's why it is technically a theory. So, first of all, everyone has heard of electronics because, gee whiz, that's how we're able to talk to each other, electronic means, right? And so that means the electrons are moving back and forth and carrying our sound, the sound of our voices, our images, and what have you. But electrons actually spin like little basketballs. So I always have the image of Metal Lark Lemon spinning that old basketball back in the old days. And so when people think of electrons, they should actually think of that image, that electrons can spin. And so the peculiar thing about electrons is that you can never slow them down, nor can you ever speed them up. The only thing that you can do different is spin clockwise or anti-clockwise. And it turns out the electrons are not the only things that have this property. The proton and neutron have this property, for example. On the other hand, light, everyone knows about light and particles of light and all of that goes back to the ancient Greeks. Light, on the other hand, actually spins at twice the rate of the electron, which is like kind of curious. And then finally, in 2012, we finally, as a species, found a particle that doesn't spin at all. It's called the Higgs boson. And so supersymmetry ties together why all of these different things might be in nature. But like I said, right now, it's just a piece of mathematics.
Gotcha. And why do they call the Higgs boson the God particle?
Well, I'm going to tell you the real reason, and then I'm going to tell you what people think. For many years, a lot of physicists at different laboratories were searching for this thing because it was predicted in the mathematics around 1968 or 72, and it wasn't discovered until 2012. And so that's the way theoretical physics works. We look to math to guide us to go look for things, and then we go look for them. And so in one of those sets of searches for the Higgs particle occurred in the United States at a laboratory in Batavia, Illinois. It's called the Fermi National Accelerator Lab. And the director of that laboratory was a gentleman who had become the recipient of a Nobel Prize. His name was Leon Lederman. And one day someone in frustration was talking to him about the not being able to find the Higgs. And he said, "Where's that GD particle?" And that's the first time the word God was attached to the Higgs particle. Since then, people have cleaned it up a bit. So, people say, oh, it's going to be the one that controls blah, blah, blah. But that's the original definition.
Gotcha. And so with supersymmetry, what does that have to do with supergravity or superstring theory?
So if you look at all the particles that we know about now, there's an imbalance. In fact, we know about many more particles that are like the electron, we call particles with that property called fermions. Then we see particles that share the attributes of particles of light or the Higgs, which we call bosons. And so supersymmetry says, imagine a piece of mathematics where the two numbers are equal. Everything balances out. And that's why we say symmetry, because it's a balance. And so if you look at supersymmetric equations, and that's what I've been doing since I was a graduate student at MIT. I was the only graduate student at MIT who thought this stuff was interesting from about 75 to 77. And then I got my PhD and I've continued to look at this math. But when you look at the Higgs particle in the presence of this idea, you can begin to understand why you should expect a Higgs particle. And even more so, the mathematics predicts that there will be at least 4 other things that we should go looking for that have properties of not spinning at all, like the Higgs boson.
Wow, that's incredible. And so I know you've spoken extensively on mathematics and reality. And what is the role of mathematics in this supersymmetry? Does it describe actual physical structures that exist within the universe?
It describes physical structures that may exist in the universe. Especially when I talk to the public, I try to make a very sharp distinction. Physics is not a faith-based operation.
Yes.
In physics, we have got to see Mother Nature provide us the evidence before we accept it. On the other hand, we must be allowed to think about what-if questions. What if nature is a little bit different than the way that we see? So, for example, everybody knows about gravity. But with this principle of supersymmetry, there's something called supergravity. It's a modification of Einstein's work. And in fact, that when I was a postdoc in the period 1977 to 1980, I was at Harvard, and a collaborator of mine named Warren Siegel and I were looking at this modification. So the thing about math is I tell people math is really extraordinary. It is our species' most exotic and eloquent language. What do I mean by that? Well, it's exotic because so few of us speak it well. Almost nobody speaks mathematics well. That's what makes it exotic. On the other hand, many of us believe that there are probably other intelligent life forms in the universe. And if they ever come here to visit us, hopefully with peaceful intent, the only language that we will probably share with them will be mathematics. And that's its eloquence. So mathematics is this really strange thing. It's a form of human language. Not many people speak it well. And I don't pretend, by the way, to speak it well myself. Although I tell people I speak a slang version of mathematics. I'm talking slang here when I do math. I look to real mathematicians to clean it up and make sure it's precise to their standards, because that's what guides science.
Right. Absolutely. And I saw that you had done some work with NASA in the field of extraterrestrial research or communications, or was it mathematics, or exactly what was it? So I think I applied to be an astronaut when I was young. And so that's the closest I ever, and they told me no, by the way. So that's the closest I've ever actually worked with NASA. Yeah.
However, I've been on advisory boards. So for example, and I've written scientific papers about what might be seen related to this idea of supersymmetry. So, we've actually used a math to say, well, if we use this math, how does it change what people think we'll see? And I've written several papers on that over the years, but that's the closest I come to working with NASA. Although I had a friend who became an astronaut. His name was Ron McNair. And Ron and I were friends in graduate school. Most people don't know that Ron had a PhD in laser physics, but he did before he became an astronaut.
Wow, that's incredible. Your work to me, man, has just been so inspirational. I remember I saw you on a panel one time with Neil deGrasse Tyson, he was actually hosting the panel. You were on a panel of theoretical physicists and I guess experts in supersymmetry. And you had started talking about this symbol that I'm sitting in front of right now, the Adinkra codes. Can you give us some insight into Adinkra codes, what they are, and how they may explain what's going on within the fabric of the universe? You know, it's something very interesting that I discovered during my research. I learned something about the Dogon tribe. The Dogon tribe are located out in Mali, Africa. And one thing that's really interesting is they have these very sophisticated symbols. And these symbols are called Adinkra symbols. And we know that today I'm talking to Professor Sylvester James Gates about Adinkra codes. Now, when I began to look at their symbols and what they have now woven into fabric and everything else, all of a sudden you begin to realize these also look a lot like the Adinkra codes. Matter of fact, some of them are identical to these mathematical codes that Professor Gates calls error correcting codes. So when you take them from a two-dimensional format, if you can imagine them becoming three-dimensional structures, all of a sudden they become these mathematical codes, these encoded symbols with information. They have so many dozens of these symbols, but just four to mention: the Gaia Name, which represents or expresses the omnipotence of God. And then they have the Sankofa, which signifies learning from the past. And then they have one called Dweninmen, which is also known to represent strength and humility. And they also have one called Adinkra Hene, which is a symbol for authority, leadership, and charisma. But ironically, those codes also seem to be very interestingly close to some of these mathematical codes that make up this supersymmetry that Professor Gates talks about. So let's dig a little bit deeper. We're going to get back to Professor Gates.
So, yes, I'm happy to always talk about these because they are my mathematical intellectual babies.
Yes.
These are things that I, along with another physicist in 2005, we were studying equations, the kind of equations everybody studies, and we suddenly realized that inside of these equations there are smaller pieces of mathematics. It's a little bit like, you know, if you look at a substance, people will tell you, oh, if you have a powerful enough microscope, you can see the atoms inside the substance. And so we discovered inside of the math smaller pieces of mathematics that no one had ever realized were there. And it turns out that these smaller pieces of mathematics could be illustrated not just by writing equations, but by representing the equations as pictures. And what is sitting behind you is one of these pictures that represents some of the equations that, if we live in a supersymmetrical universe, will describe some forms of matter and energy we've never seen before.
Wow, incredible. And I heard you mention that web browsers and search engines use error correcting codes. And in some way, these Adinkra codes also represent error correcting codes. Is that true?
That's all true. You've done your homework very, very well, Billy. This is, in fact, a shocking truth. So, you know, if you ask scientists what's in the world, we'll start talking about atoms and electrons and protons and neutrons and all of those sorts of things. And we use equations to describe these objects. Well, it turns out that if this balance, remember I talked about the balance between bosons and fermions, if this balance is really present in nature, it turns out that from our exploration of these symbols behind you, we found out that in order for every piece of matter and every form of energy in the universe to exist, if they exist via these equations demand that they are related to error correcting codes, the kinds of error correcting codes that make computers work. Now, this statement is so astounding, and let me just make sure people understand. It's not that I'm doing all this work by myself. I am intensely collaborative, and so I love to work with people. And like I said, we first discovered these things with Michael Fox. A few years later, I formed a group of 3 mathematicians and 3 physicists in order to study these things. And this collaboration, and let me name my collaborators if I may, is Charles Duran, Kevin Ega, Greg Landweber. They were the mathematicians. On the physics side, it's me, a friend of mine who's a professor at Howard University named Tristan Huch, and Michael Fox, one of the original people who, a person that I found this work with. We were studying these things and we realized that in order to define matter like we see it in our universe, or to define energy as we see it in our universe, you have to use error correcting codes. This result was so astounding that for 3 years we couldn't get any physics or mathematics journal to publish our results because nobody believed it.
Yeah, it's so powerful. I mean, the implications are incredible because now we're talking about, are we living in a holographic universe? I believe that there's a creation here because I think the mathematics proves that we're living inside of a creation, but could these Adinkra codes possibly be some type of evidence if it's, that there is a creation?
There certainly are. If you go online, and I'm sure you've done this, there are many people who interpret our results as implying that. I'll never forget the first time I saw an online comment about these results. It was from a young person who was a Catholic, who followed the Catholic faith, and effectively he wrote this article that said, if these codes are there, this person said they knew who wrote the codes, and of course they were talking about a creator.
Right.
My view is different about this because, as a scientist, what I know are a couple of things. First of all, science can never be used to disprove faith. This shocks people when I say it, but it's actually true. Because if any scientist ever walks up to you and says, I have a piece of science that disproves your faith, there's a very simple question that you can ask them, which is, how uncertain are you? Because if they tell you they're not uncertain, then they're not talking about science. You see, science is always about uncertainty. So you can never rule out absolutely belief by using an argument based on science.
Gotcha. You're talking about the uncertainty principle, possibly, right?
This goes beyond that uncertainty, but yep, that's certainly part of it. Yep.
Okay. Wow. Incredible. And, well, when you talk about, people talk about the fact that we could be living in a creation, not just spiritual people, but also people just following the science, researchers, like myself, looking into what is this realm that we're living in? How was it created? What is the code that's running it? And I think that, from my perspective, it seems as if we're living in something that mathematically is created. Who is the programmer or programmers? I don't know. Did it start spontaneously? Maybe that's also a possibility because, like you said, uncertainty. We can't say anything with complete certainty. But it really, when I started studying fractals and the Mandelbrot set, it really started getting me thinking, is this universe fractal based? And if it is, have you seen any research into fractals and maybe the theoretical physics and supersymmetry that you study?
Not in the work that I have been responsible for introducing into the physics conversation. In fact, it's interesting you should ask that question. This is something I've actually wondered about for years, is whether we would bump into fractals somehow by studying these objects. Like I said, we first proposed their existence. And remember, when I say objects, I'm talking about mathematical objects. I'm not talking about
yes.
Right. So we have, in studying these mathematical properties, we have yet to see the emergence of fractals, which is a little bit surprising to me, but who knows? I don't claim to be any kind of all-seeing wonderkin. In fact, I tell people I'm a simple country theoretical physicist, and I dig mathematical ditches. That's what I do. And so I follow my nose, I work very hard, and I try to surround myself with people who are incredibly gifted in mathematics and physics, and we work together to unearth these really weird things. We don't know what they're going to mean, but if we're very lucky, we have found something profoundly interesting about our universe, as is implied by the comments that you just made.
Oh yeah, absolutely. Have you found any potential technological potential with, this knowledge, this information about Adinkra codes and error correcting codes and what it could mean and what the implications could mean? Do you think there's any technological output that we could see from this?
So let me tell you a true fairy tale. In the 1860s and 50s, there were people in England, in particular a man named George Johnstone Stoney, who most people have never heard of. This person, because he was doing electroplating, I don't know how many people in your audience are familiar with electroplating, where you use electricity, put one metal on another and bind it. He was a chemist and he was working with this, and he thought, I could understand what's going on if there's something in nature smaller than an atom. Now, in Western science, the idea of the atom goes back several thousand years to the ancient Greeks. And no one had ever thought about something smaller than the atom, but this particular scientist did. Well, it turns out that the thing he was thinking about now actually, he named it. It's called the electron. And so does it have any technological applications? Oh man, does it. So, but this story, the reason I tell this story is because that's the time scale to think about what people like me do. It's not gonna show up in a decade. It may not show up in a century. But if we are lucky and we have gotten it right, maybe on the order of several centuries, some incredibly interesting technology will likely emerge. And that's the best I can tell you.
Right. I got to ask you, how in the world did you get into these types of studies? What was the factor that said, drove me right into learning this kind of information?
Well, in some sense, it's the universe itself, and I'll have to explain that. Yeah. So, my father was a soldier in the U.S. Army, and he went in during World War II. And after the war was over, he got out, but he didn't rejoin the Army. So that when I was born in 1950, he was back in the Army. When I was 4 years old, he was stationed at an Army base in Canada. Most Americans don't know that up until the middle 60s, the U.S. military actually had bases in Canada that were left over from the Second World War. So one of these bases is in a place called St. John's, Newfoundland. And Dad was stationed there, and they had quarters for dependents. So my father, my mother, father, and my siblings, we all lived in the housing that was provided by the Department of Defense. One day, my mother took me to see a movie. It's the first movie I ever remember seeing in life. And I was 4 years old, and I have carried pictures in my head of that movie for now 70 years. So maybe 15 or 20 years ago, I started using what's in here, combining that with the internet and the web to see if I could figure out what movie this was. Because that evening, my parents used to say, when Dad came home from work, I told him I wanted to become a scientist. So my first time saying I want to be a scientist was 4 years old, apparently. Now, I don't remember saying it, but that's what my parents tell me, and I trusted them.
Wow.
So
well,
I was always headed in this direction because of that movie, and because my mother took me to see that movie, and also because of some strange things in our family. So my grandfather was a sugarcane farmer near Minden, Alabama. It's the closest large town. And he could neither read nor write, but he could do arithmetic. At least that's what we are told in the family lore. Why is that important? Well, farmers often have to buy implements and seed on credit. You go to the store, you have a credit account, you buy your plows, maybe the harnesses for your donkey or mule, and the seed that you're going to plant. And you buy it on credit. You get it on credit. There are ledgers that are kept by the storekeepers. And of course, this is like, we're talking about the 1900s, 1910s, 1920s. My dad was actually born in 25. So my grandfather was farmer. He was not a sharecropper. He owned land, but he was a farmer. And so when disputes arose between the white store owners, because black people basically were not allowed to own stores at that time, and certainly not in the South.
Yeah.
When there would be disagreements over the ledger, my grandfather was the person both sides trusted to look at it and get the numbers right. So it's kind of peculiar. I mean, it's a peculiar part of our family that my grandfather could neither read nor write, but he could cipher, as the expression was called in the community. He could cipher with numbers. This of numbers also showed up in my father's life. He never finished high school because he joined the Army at age 17. So he joined the Army before he finished high school. But while he was in the Army, he got his general equivalency degree, GED. And part of that was mathematics. And so I remember as a kid when we were living in Texas at Fort Bliss near El Paso, I remember watching my dad study mathematics, and he clearly enjoyed it. So you can see this really weird thing in our family that my grandfather was kind of into math, even though he was a sugarcane farmer. My father was a soldier. And my dad actually used mathematics, for example, in trying to figure out when different divisions would, different groups of soldiers would meet when they were on march. And he has this famous story that he told us about impressing a white officer because he had this ability in his head to essentially calculate times and distances and make predictions when the groups would meet. So he was into mathematics. I've always loved mathematics. And I have a daughter who studies black holes in mathematics. And her twin brother is actually a biologist, but he studies brain cells. He actually grows brain cells on test tubes. And that's, there's math involved in that. So I like to tell people math is actually our family business now for 4 generations. It's really peculiar, but it's kind of true.
Wow. That's incredible. That's an incredible story. I mean, and clearly in some way, you guys are passing down some incredible DNA when it comes to mathematics.
I agree with you, Billy. That's the only explanation I have for why we have this persistent attraction in my family that we can document to mathematics, something most people can't stand. And like I said, for us, it's to show you how crazy it is. Let me tell you a story about me and when I entered school. Yeah. When I started first and second grade, I was having trouble with the language arts. I was having trouble learning to read and write, but I was having no trouble with arithmetic. And so I often tell people that if you see something I've written and it's got spelling errors or punctuation or grammar errors, please forgive me, because you see, English is my second language. Mathematics is actually my first language, because I was doing that just fine when I entered school. And like I said, it's weird, but it's true.
Yeah. Well, you know what? You were talking at the base root language, which is mathematics anyway. So you were talking the universal language, because I believe that is the language of the universe, literally mathematics.
It's the closest language we humans have developed for having that intimate conversation.
Yes, absolutely. And, when you get into quantum mechanics and quantum physics, what role does that play in your studies or with what you've researched over the years?
So let me start with my introduction to this object of this idea of quantum. If you look at our society today, the word quantum is everywhere. Quantum computing, quantum information, they're going to, quantum, right?
Yeah.
But my involvement with quantum goes back to when I was 8 years old, sort of. We were living in El Paso. My father brought home Encyclopedia Britannica. I like to tell this generation that was our version of the web, was the encyclopedias, because we look at the waiting. Because that's when we had homework, we would go to the encyclopedia to look it up, right? So one day I was just thumbing through the encyclopedias, and I came across this thing. I couldn't figure out what it was, but it had equal signs and plus signs in it. So I knew it was mathematics. In my second year as an undergraduate at MIT, I saw this thing again, It was the Schrodinger equation, which is in fact the mathematical basis for quantum theory. So the equations I study all involve quantum theory. Those are the only kinds of equations I study.
Gotcha. And I think some people get confused between quantum physics and quantum mechanics, even though they both go one and the same. What is the distinction between the two?
So quantum mechanics, I would say, is kind of a more mathematical framework. It sort of sets the stage for how to incorporate quantum effects into observations. Quantum mechanics turns out to be essentially how our species first applied quantum ideas to how atoms work. So it's a more limited application of the ideas. That's the way I would parse those two terms.
Yeah, no, that makes total sense. And one of the most incredible experiments that I talk about from time to time on my podcast or when people are interviewing me, they're asking me about the nature of reality, and I bring up the double slit experiment.
Yeah.
And sometimes it's just best for it not to come out of my mouth. Can you break down the double slit experiment a little bit for those who may have never heard of it before?
I can, but I'm not going to be any better at it than you, Billy, because so one of the people that I had the great pleasure to have as a kind of a research mentor was a physicist named Richard Feynman. I was a postdoc. I was a postdoc at Caltech from 1980 to 1982 in the research group that he headed, along with another Nobel laureate named Murray Gell-Mann. So I was a postdoc in that group. I refer to Feynman because Feynman says nobody understands quantum mechanics. If that genius can say that, then I'm going to stick with it. I don't understand quantum mechanics. I can write some equations and tell you what the equations say, but I don't have an intuitive feel, and I've never met anyone who intuitively has a feel for what the nature of reality is when you start including things like quantum mechanics, with its strange attribute of an entanglement, by the way, which is basically says that if you start with two particles that are quantum mechanically interacting with each other, if they separate even over long distances, somehow there's something like a ghost-like communication between the two of them. And this effect is actually being developed not only by our government, because if you can actually get technology based on this, you will have communications that no one can break into. It's like having a code no one can break. And so the Chinese government is also investing in explorations. In fact, they have some of the world's most accomplished scientists working at this question. So even though it's weird, it may yield technologies that can have extraordinary impacts on humanity.
Oh, absolutely. I mean, I could see just with quantum entanglement of two communications devices, one out in deep space, maybe you send a group of satellites out into deep space out by Jupiter or Saturn. And so you park them there, right? And then they have a quantum entangled communications sender and receiver on it. And maybe the home base is somewhere, I don't know, Houston, right? Texas, or the coast of Florida. And then you take a vacation out to go see the rings of Saturn or Jupiter. Instead of sending back a signal back to Earth, which would take months for them to get the signal at the speed of light, and then months for them to return that signal back to you, you can actually just send your signal to the satellite that has that quantum entangled communications receiver in it, and it will transmit that back to Earth instantaneously, and then you can get a response back. I think at that point, the only delay would be how long it takes for the satellite to transmit back to your ship, depending on where you are in location to that satellite or array. So by that method, it could be incredible.
That is the dream, Jim. That's the dream, Billy, and maybe it will become reality. None of us can say with certainty that it won't.
Mm-hmm. Yeah, right. You use that a lot, but with certainty, I get it. But that would be an amazing piece of technology. That would really make deep space travel. I mean, like for just vacations, for example, space vacations, it would make it a true reality because the dangers of deep space travel are immense, but when you can at least be in communication, I think that cuts down some of the apprehension.
That's exactly right, because if you have such communication, then you have access to all the information back here on Earth, more or less at your fingertips, and that might be very helpful to get you out of a dangerous situation.
Exactly. Yeah, that would be so powerful. When you're teaching all of these incredible, intricate topics, because I know you're teaching right now still, and you're like, how do you lead in with this information? Are these people that are coming to your classes already geniuses, or how do you begin to break down these incredible theories?
So, first of all, I have been teaching now for 52 consecutive years.
Wow, that's my age.
Really? I'm surprised. You look much younger than that.
Oh, thank you. I appreciate it.
But the first time I stepped into a university classroom to teach was in the summer of 1972 at MIT, and I was teaching a course in calculus. And so, in fact, that class is really why I became a professor, because before that, I really wasn't particularly interested in teaching. So how do I teach? Well, the first thing I try to get my students to understand is that ultimately they have to be able to teach themselves, and that I'm just kind of a translator. I'm trying to translate ideas in such a way that they resonate with things my students already know. That's one important thing. I learned I could teach myself after my freshman year at MIT. I figured that out, and that's part of the way I got through MIT was, professors stand, they talk, but you have to own it, right? And the only way you can own it is that in some sense you have to take it internally. And so that's the first thing I try to get across my students, that I can be a guide, but I can't really teach you, but you can learn via what I'm saying. So it's translating from crazy math to ideas that already exist in their heads. In fact, that image behind you is is one example of that, because when I and my colleague first discovered these mathematical things, we would talk to other physicists and mathematicians, and even they couldn't understand us. And so at some point, Michael and I hit on the idea that if we draw pictures that had enough data and information in them, then we could communicate these ideas to people. And so that's what I try to do with my students, that same kind of process.
Gotcha. Now that's exactly the method that I use to try to teach the people that I speak to through my digital medium, through TV shows, through workshops and classes. Same exact technique. The ultimate way to teach is to get someone to become their own researcher.
Right.
That is the trick.
That is the trick. And like I said, I learned that at MIT during the summers. I was stunned. I had never known I could teach myself, and yet I did. And ever since then, that together with using the power of the mind. I'm not a neurophysiologist or anything like that, but I talk to people who study the mind. And one of the things that I've learned from them is that there are kind of two of us, of every one of us. There's our conscious mind, but there's also a subconscious. I'd like to tell people that it's your subconscious that makes you pick green over red as your favorite color. It's not your conscious mind. It's just a feeling that you have, and that comes from your subconscious. And so one of the things that is often said about the subconscious is that it actually processes orders of magnitude more information and data than our conscious mind. And one of the principal tools by which it does that is visualization. That a large part of the data handling capacity of a human brain is wrapped up in processing visual data. And so when I translate equations into an image like that behind you, it means that part of the mind that works on visual and visualization can suddenly become involved, even though it's your conscious mind who wants to do the math. And in fact, that's what happened. I mean, I know this is what happens because this is what I actually experienced. This is going to sound weird, Billy, but I actually sometimes
dream. No, it's not going to sound weird.
I sometimes dream in mathematics and come back and talk to other people, and the dreams are verified. And so I know that one's subconscious can actually get engaged in mathematics. And I'm not the only person. In fact, I like to point people to a mathematician, an Indian mathematician by the name of Ramanujan. If you know the name, you can go look it up. He is the most incredible example in history that proves that the human mind does mathematics in dreams and at the subconscious level. And the other thing I tell people is, how many times have you gone to sleep and said, "Oh, let me sleep on it," and then in the morning, all of a sudden, there's something there? Where did that come from? Right? Where did that solution come from? It's your subconscious mind at work.
Yep. That's right. It's processing possibilities, possible outcomes.
Exactly.
Yep. Because everything exists in superposition. So the mind is going through all these hoops and jumps and everything else while you're sleeping, and it's coming up to its own conclusions.
Yep. And sometimes it communicates those to you.
Yes. And sometimes it communicates, but sometimes the people don't listen to their own voice.
But that's true too. It's very interesting to come to trust that part of yourself. Like I said, I learned to trust it learning calculus, basically. Because it sounds like it's magic or demons or angels. I mean, it sounds like something not part of the human experience, right? But that's the way minds can work.
Yes, I agree 1,000%. I mean, this has been an incredible discussion. Matter of fact, I'm writing a book right now called Fractal Holographic Universe, The Matrix Code Revealed.
Oh my goodness.
And it's going to be a deep book. And in that book, I actually reference some of the work you've done in Supersymmetry, giving you full credit. I don't go on too much about it, but I definitely reference it in the book. And so I'll definitely be happy to send you a copy of the book to take a look at it and for you to have a copy.
Love to see it.
Yeah. It's going to be an amazing book. Be out probably in about another month. It'll be out, and I'll make sure I get a copy sent out there to you.
Thank you.
Yeah. Before we wrap up, what advice would you give to young scientists who are intrigued by, the fundamental questions of the universe and supersymmetry and supergravity and quantum physics, quantum mechanics, and trying to unravel it all? What advice would you give them?
Well, this is a question I often get, Billy, and I always start by saying I don't give advice. Because to give it good advice, I have always thought you need to know a lot about the person you're giving it to. And that's almost never the case.
Wow.
What I am willing to do is talk about my own journey and what was important for me to be able to reach my dream, because for many years I could not have stated what it was I was trying to do, but I can now. It has been my dream from before I could enunciate it to find a piece of mathematics deeply buried in nature, and that provides an accurate description of something. And I may have done that in my life. So the first thing I tell young people is, for me, the first secret of getting to where I am is to ask a much simpler question. You don't ask, how can I be successful, or how can I be famous, or how can I make a lot of money? For me, the first question is, what do I care most deeply about? What's most close to my heart? Because if I can answer that question, particularly if I'm trying to do something, if it's close to my heart, I'm probably willing to work really hard to get it to happen. It's something I will do all that I can to keep alive. And sometimes that means going through terrible pain and suffering. Many times I've given talks to young people, and they've assumed that I sailed through MIT. That's not true. In fact, my first 2 years at MIT were the most emotionally stressful time in my entire life. I used to cry regularly over not being able to do homework. And what it taught me was some things about my subconscious, because this was causing extraordinarily deep pain for me. And I eventually figured out that if I didn't find a way to release this positively, that it would destroy me. Now, the release is kind of funny. I learned to bowl, Billy. Seriously, I learned to bowl.
Wow.
I tell students, I used to use 16 pound ball, 90 feet of waxed wooden lanes, 10 pins down at the other end. And sometimes I could imagine the faces of my teachers on those pins. And I would just work the frustration out. And it worked. Even though I was terrible at taking tests, I could do this to feel better about myself. Because I got to be very proficient at bowling. If you're a bowler, you perhaps know that a perfect game is 12 strikes in a row. I have thrown games of 10 strikes in a row in my life. So I was bowling at a professional level, and it was because I needed a way to get rid of these negative emotions, and that for me was the outlet. So the other thing, reason I share this is I tell young people, you must manage together with your subconscious to find a way to be successful, because that's what I did.
That's so powerful, because you're really talking about the fact that you literally followed your passion, and you didn't chase after fame. You didn't chase after Nobel Prizes. You didn't chase after money. You followed your passion, and that attracted to you the success and the level that you are right now in society and in scholarship and everything else. And I think people need to hear that message. Everyone who's listening, make sure that you do something that you're passionate about. But it doesn't mean that you're not going to have any obstacles in your way. You're going to have to overcome those obstacles and maybe even find an outlet for the frustration, like Professor Gates has done. But you can do it. Professor Gates, it's been an honor having you on here. The last thing I want to do is I want you to mention the nonprofit that you have.
Well, it's not my nonprofit, but it is the nonprofit associated with my high school alma mater. It's called the Jones High School Foundation. And every year, my old high school has an award for the best math or science students. Actually, there are two of them. And since 2004, I have made sure that every student who receives this award is handed a check for $1,000. And it's not a scholarship, it's an award. It's an award that says you have done something extraordinary, and the world will find a way to recognize you and lift you up. And I'm just doing my little part here. And there are no restrictions on this. It's not a scholarship. I don't care how they spend it. But I want them to know that that kind of dedication has a reward, even if you can't see it at the time.
Fantastic. And it was an honor for us to be able to donate to that nonprofit, which we have already, as you know. And we will put a link to that in the caption of this video or this audio to give anyone who has any feelings of wanting to be able to be a part of something huge to help young people to click that link and make sure they put a donation in as well.
May I say something else, Billy?
Oh, absolutely.
So my high school, I'm a high school alma mater, is in Orlando, Florida. Jones High is mentioned is the name. But if you Google the Paramore District at YouTube, you'll find out it's considered the worst hood in Orlando, or one of Florida's worst hoods. Wow. So out of this neighborhood in the 60s, I found all I needed in great teachers in the high school who pushed me to be the best I could be. None of us had a lot of money because it's an economically distressed part of Orlando. And racial segregation was strictly the rule. And so the white high schools, as we called them, had much better financial support than Jones. But at Jones, we formed a chess club. We challenged all the other high schools in Orlando, and we never lost a match.
Wow.
And so that's what working to one's dreams, having people support you like we had our teachers, that's what it did for us. And in fact, there are stories about this that still persist to this day, that this one single black high school in Orlando never lost a chess match to any other high school it played.
Wow. That's an incredible accomplishment, and a testament to the fact that you guys did not take the victim mentality, that you took the PTG mentality, post-traumatic growth mentality, and strived and thrived. That's amazing. Phenomenal. It's been an honor. Thank you for coming on. I'd love to have you on again sometime in the future, because you're just a wealth of absolute knowledge.
Well, thank you, Billy. I just hope I don't run away any of your audience members today. We're not going to go back again.
No, no. They're gonna love this. Trust me. I have a very intuitive mindset. People who have a mindset for knowledge and gaining research and knowledge and just thriving in sciences. I try to bring them as many, I call it receipts, as possible, because when I'm talking about some of these topics, I like to try to back them up with real science, something that has a base root in some type of a science or a theory, to give them some basis to say, okay, there's a foundation stone here to build on. It's not just coming off the dome. It's not just woo-woo. That there's something there that they can bite their teeth into. And that's what I try to do. So it's an honor to have people like yourself on the show. I had Avi Loeb on here before. I'm going to have Michio Kaku on soon. It's just an honor to have real science minds and come bring some absolute unconditional facts based on the theories and the research that you've done. And then, of course, the uncertainty as well.
Thank you. If it doesn't have uncertainty, it ain't science, y'all.
Boom. This is Billy Carson, and I would like to announce the release of my new book, Fractal Holographic Universe, The Matrix Code Revealed, now available on forbiddenknowledge.com.
Boxes, I cannot fit in the boxes. Stop it, quitting was never an option. Exhausted, this passion is never exhausted. And you cannot stop it, nah, you cannot stop it. Quitting was never an option.